we have two speakers for you. Our first is Jessica Taylor, who's the Principal Investigator for Globe Clouds. In 2021, more than 220,000 observations of clouds and sky conditions were documented and submitted to Globe's worldwide database. And then second, Dr. Jay Welsh is a research scientist for NASA Globe Clouds and specifically works on cloud gaze, which is based out of the science directorate at NASA Langley Research Center with science systems and applications. I will hand it over to Jessica Taylor. If you can share your screen.
Wonderful. Thank you so much. Can you hear me all right?
Yes.
Great. All right, let me go ahead and get this presentation started because on the second slide here, we're going to be asking you during this presentation, we welcome you to do a little double dipping and multitask. And we'll be spending a little bit of time actually going over an observation that can be made through our app called Globe Observer. So if you don't already have it, I'm going to encourage you to go ahead and download it as we get started, because we will take a break here in a little bit to go make some observations together, separately, virtually. So if you're able to go outside, we welcome you to make that observation. So you can find the Globe Observer app wherever you get your apps. So it's available for iOS and Android devices. And it's free. Go ahead and download it. If you cannot access the app for whatever reason, we also do online have data entry sheets. If you want to do a paper form, that's available. And of course, you're always welcome to just sketch what you see, so that we'll take time to do that. All right. So my name is Jessica Taylor, as mentioned. I'm the Principal Investigator for Globe Clouds working at NASA Langley. And I do have colleagues joining me today. Jason will be speaking in a little bit here. And Marilei is our project scientist, and she's going to be answering questions in the chat. I just figured with folks downloading the app, if you have questions, feel free to post them in the chat, and she will be responding because while I'm presenting, turns out I can't see the chat. So let's get started talking about Globe and this amazing community. And I want to share with you a little bit more about myself, because I have a very strong connection to the Globe program. I've actually been involved with Globe for longer than I've been with NASA. So I grew up in Florida, and it was my interest and love of thunderstorms that led me to want to get a degree in meteorology. And I was just taken aback by how a teacher in my high school asked me to do a research project. And I had learned that scientists still were learning about lightning. And I just thought that was really cool that you could get a job learning about something that was of interest to you. And that's why I chose to get a degree in meteorology. So I went to Florida State, and at Florida State, I became involved in the Globe program, which meant as a student, I was collecting daily atmospheric measurements, going outside to do temperature, relative humidity, precipitation, even aerosols. And that is what I credit with my confidence and my belief that I could become a scientist, because I was getting that practice on a daily basis and really beginning to ask better questions and do better analysis. And so that is exactly what led me to NASA. And I was in the area, and NASA was looking for someone who had experience with the Globe program. So of course I jumped up and down wildly and said, I actually do. So that is why I'm thrilled to be able to share this with you, because I have such a strong connection from my past as a student. I am married to a climate scientist, and we do have two beautiful girls who really like to help me make cloud observations, and their favorite to identify are contrails. So let's talk a little bit more about the Globe program. I know many of you are somewhat familiar with it, It has an over 25-year history, which is amazing considering how many federal agencies support this program. It is currently sponsored by NASA and receives support from NOAA, National Science Foundation, and the Department of State. The Department of State gets involved because other countries that participate in this program sign formal agreements to participate. And we have over 120 countries that participate in this program. And everyone around the world is using the same protocol or scientific steps and instrument specifications when we're making these measurements. So we know that the data that we're collecting here can be comparable to somebody in another part of the world. Now, GLOBE got its start as a school-based program. Scientists and teachers, educators got together to develop this program as a science and education program, really emphasizing both of those high quality programs from a science perspective and education. But in 2016, we expanded and we welcomed the general public citizen science community in participating in these observations as well. And so that's really what helped us grow so much just over these last few years. We've always had multiple tens of thousands of schools that participate, but now we have over 200,000 citizen scientists that have joined in this effort of collecting data. And they do that by using the GLOBE program's Globe Observer app. And within that app that hopefully many of you are downloading, there are these 4 tools that are available for the general public. And these were selected because we felt that through the app interface itself, we could help walk somebody through the steps and procedures in collecting that measurement. And so I'll briefly go over these before we get a chance to break and practice with the app. So within the land cover tool, we're asking communities to document their land cover site. And when I say land cover, that could also include bodies of water. So what's on the ground? And similar to clouds, you're asked to take photographs, and you can go a little bit further. There's this, if you can see the cursor on the screen, there's this land cover expert button. If you do a little bit of in-app tutorial, you can also do some estimation of what's on your ground cover. So you're going to estimate, say, for example, grass versus tree, things like that. And then this will help us, we can compare it to your satellite observation. And in fact, you'll see it right directly in the app, which is pretty cool. Mosquito habitat mapper. This is hugely popular, and it's also one of the opportunities really for stewardship, if you think of it that way, because here we're teaching about what are possible mosquito breeding sites and really asking people to eliminate those breeding sites. You can also go further within this app by identifying mosquito larvae and submitting that to us as well. The trees tool, super cool. We turn your phone into a clinometer. So you don't have to be carrying the clinometer with you. The phone becomes a clinometer to measure the height of a tree. And you do it right directly inside the app. And again, if you want to go another step farther, you could measure tree circumference as well if you have measuring tape for that. And then, of course, the one that we're going to spend the rest of our time today talking about, which is Globe Clouds, where we're asking you to take pictures of the sky and tell us what you see in as much detail as you possibly can. So before we go out, why would NASA care so much about all of this? So I have a short video about why NASA's interested in clouds in the first place.
When you see fluffy white clouds in a blue sky, you know you're usually in for a pleasant afternoon. A sky full of thundering dark clouds, and you'd better find an umbrella. What could be easier than understanding clouds, right? Ha! When it comes to climate, clouds are far from simple. We know they're a very important piece of the puzzle, but they're hard to fit into the big picture. Why? One huge reason is that clouds both cool Earth by shading it from the sun and warm Earth like blankets, trapping the heat it gives off. Clouds cover around 70% of the planet at any given time, so they play a big role in determining how warm and how much water Earth gets. The thing is, scientists aren't sure how climate change is affecting clouds, or how clouds are affecting climate change, whether they're tipping the balance towards more warming or cooling, and how this will affect our planet in the future. For example, some places may get more rain, and some other places much less rain in the years to come as the climate changes. So NASA studies clouds from all angles to help scientists make their climate forecasts a lot less cloudy.
So clouds play this really important, interesting role in understanding energy budget. Now, there are lots of different parts of the Earth system that impacts energy budget and whether or not we're at a balanced budget, so the amount of incoming solar energy equaling the amount of outgoing. But clouds really are one of those tricky ones because, as you saw in the video, some of those clouds cool and some of those clouds warm. So let me just take a moment here to kind of go through this diagram. On the left side, we have the yellow lines are representing incoming shortwave solar radiation. And we see that a high, thin cloud, like those represented on the left side, that sunlight comes right through, right? So if you think about when you've been outside, and sometimes you look and you're like, oh, maybe the sky's a little, kind of milky in color, but then you see actually it's not the sky, it's the fact that you have cirrus everywhere or a thin cirrostratus. Those clouds are letting all of that sunlight through, but they act as a trapping blanket for Earth's outgoing energy. They're so cold that what they emit out is much less. Now, a big puffy cloud, on the other hand, now that type of a cloud tends to reflect some of that sunlight back out to space, and it is emitting a fairly equal amount as the Earth is here. And so these clouds overall have a cooling impact. And so different clouds can cool versus warm. And so that is one of the big questions when we're trying to better understand energy budget, along with how that impacts climate, and vice versa, whether or not any changes to climate are impacting clouds. And so NASA has a huge role to play in monitoring Earth, of course, but in particular, NASA Langley has been involved in this idea of energy budget for many, many years. And we lead the CERES instrument, which is on multiple satellites. CERES itself stands for Clouds and Earth's Radiant Energy System. Oh, I would get that. And the CERES instrument, what it's doing is it's taking a look at cloud properties, first of all, the clouds. And then the Earth's Radiant Energy System part is, it is the only global top of atmosphere energy budget data set where what we're doing is we're looking at solar reflected as well as Earth emitted energy, and we can monitor that. And this is an example of one of those beautiful maps, the diagram here that is developed by NASA. So that gives you a little perspective as to why NASA might care about clouds. Very important and to the hydrologic cycle, but also really important here as we're trying to investigate and better understand climate. So you can help us is where I'm going with this. You can help us better understand clouds by submitting your observations from the ground to us at NASA through the GLOBE program. And one of the ways to submit that data is through the app called Globe Observer. And a lot of people think it's basically the most fun and easiest way to submit data to us. So let me share this video with you of how an observation goes. Gives you an idea of how long it might take. So there's just some background music in this, but I'm going to go ahead and talk over it a little. So within the app, once you have created your login so that you can get to the screen that allows you to actually click on Globe Clouds, you take it out wherever you are and start making an observation. And when you open up new clouds, we will locate you using your phone to be able to do latitude, longitude, and time. Start to tell us, what does your sky look like? So if there's something in the way, you would tell us that's an obscuration, like focus fog or smoke. We've definitely seen some more observations of smoke lately, or dust. Or tell us yes or no that there's clouds. And if there's clouds, how much? And you're giving us, there's categories here, so you don't have to worry about being extra specific. Now, if there's just a few clouds in the sky, we're going to ask you to also tell us about the color of the sky itself, not the cloud. In this case, we're asking for the deepest shade of blue. And looking along the X direction, along the horizon, how clear is it? Is it usually clear all the way to extremely hazy? These two give us some idea of the aerosols in your air quality that could also be impacted by other atmospheric conditions as well. And then we want you to tell us about the cloud cover at each height, low, middle, and high, and opacity, how much light comes through. Remember, I was just sharing how important that is to energy budget. So we want to know about the opacity of those clouds. And then tell us what's on the surface. So think about this in context to a satellite image. What might a satellite see? And then the most fun part for you and for all the researchers are the photos. So you'll be trying to get this little circle into your picture angle. And what that's doing is giving you, all of us would be then using our phone at the same angle to take our photos in all cardinal directions, up and down. And then don't forget to send the data to us at Globe. That is the next most important part, is to send your data. Now, the app itself, you need Wi-Fi to download it. But then once you have it downloaded, you don't need Wi-Fi to use that. In fact, it'll just store that data. And if you want, you can wait until you get back on a Wi-Fi network to send that directly to us at the Globe program. So for those of you who have the app ready to go, I'm going to ask you to go outside and make an observation. Some of us will stay behind to answer some questions in the chat. You're also welcome to peer out your window and take a look to see what's happening. But let's meet back here at 1:25. 1:25. And I'm going to stop sharing my screen for a second. So this is what it should look like after you've already installed and created your login and all of that.
Jessica, this is Marile.
Yes. Hey.
Hi. Peter asked a question about the series data that you were showing in the chat.
Thank you. I'll try to type that in.
Awesome, thank you. And everybody, hopefully not a lot of you are here. Hopefully you are out and making observations. But if you're here and have any questions about the app or NASA Globe Clouds, Jessica and I and Jason are actually here to answer in the chat.
Hopefully you guys are not hearing my children right now. They're very
You're good. You're good.
As you said, it's Vicky Slomowski here. As you said, it's hopefully not many people, but it's -21 outside. It will take me longer to get dressed.
Don't feel like you have to go outside right now. -21. Open. Just peer out those blinds for a second so you can get
I'm
an
peering
idea.
out my window. It's very, as it's -21, it's very, very clear outside. This is great. I'm
Yes.
having a lot of fun. just out of interest. Well, I don't know if you'll be here later on for my talk, but one of the things I'm doing is collecting historical data. And I'm really, really trying to impress on people how important it is to collect historical cloud data. So we are also trying to look and see how clouds have changed, and exactly as you said, to try and get a radiation budget and see how that's changed. So we're working hard to collect cloud data from the 19th century several times a day. So it's interesting because we're also trying to reconstruct the cloud cover from several hundred years ago. So
that's amazing. I bet our community would be very interested to hear. We'll be sharing in a little bit here how we are right now in the middle of a cloud data challenge, and the theme is clouds in a changing climate. And there we have some amazing student vloggers who have interviewed their community members, teachers, elders, asking about how clouds have changed in their area. And it would be a really nice complement to that. Marile, if you can find that link to plop in the chat, that would be great.
Sorry, Jessica, can you say that one more time? I was writing in the chat.
The student vlogger video.
Oh,
Although the
of
student
course.
vlogger video is also on the Cloud Data Challenge website, so maybe just pop that in there.
Okay, perfect.
sorry, what was that? Would the students would like to know more about the historical data, you think?
I do think it would be great for us to be able to share something back to students who do this on a regular basis and have been asking these questions.
Yeah, well, part of what we're doing is with citizen science. So we're asking citizen scientists to transcribe this information. So it's a different kind of citizen science. They're not collecting data, they're transcribing historical data.
Right, right.
So anyway, so yeah, so that's part of what I'll be talking about. Or I made a video with slides because I have some difficulty. I have a disability. I have difficulty with my hands. So even after 2 years, I still have trouble with the screen sharing and the videos and everything. So I put a video with a slide with narration. So hopefully that will work later on.
Yeah, I'm looking forward to it then.
Yeah. So, but yes, that would be great. We have a lot of students working on our projects too. So we have a lot of outreach. We have blogs. We have social media, things like that. So it would be wonderful to connect the present day and the historical. So
absolutely.
Yes, that would be great. And I'm filling in from my window the observations I have. So. Perfect.
All right, as people start to return, feel free to share in the chat too what your current sky looks like. Yeah, I'm pretty overcast right now. Wow. So looking like we have some similar observations, perhaps for multiple locations. Great. Feel free to keep writing in the chat. And if you have any questions about the app itself, like I said, Marile and Jason will be trying to answer those for you. So let me summarize what you were just doing outside. And for those of you who are not able to go outside, couldn't get the app to download, or it is too darn cold to go outside, let's talk through what an observation entails. So the first thing is to find a spot to make your observation. Now, in this idea and vein of engaging the most number of people we can and crowdsourcing, we have everything here from the most ideal location being an open field to, of course, not great locations would be buildings and trees all around you. What I will tell you is make the observation, even if it's not the best location. Now, if you think you can't see the sky at all, or you can't see multiple directions, then that's okay. Don't make your observation if you really can't describe your sky. But if there are some trees, that's all right. That's exactly what, when we look at the site definition, or if you're using the app, the photos help us get an idea of what might have been obstructing your view. That's one of the reasons we have those photos there as well. So, but do try to find a more ideal location when possible, and then go in the app and start selecting clouds. You should have been able to notice that the app identified, as long as you've got location services turned on your phone, the app was able to identify your latitude and longitude location, and there's a little image there that pops up to double check us. And then you enter what was in your sky. Now, I do want to mention obscured versus overcast, because many of us had overcast skies today. Some of our participants can get confused between these two things. And an overcast sky, like what many of us have today, because there's just complete cloud cover, are clouds in the sky, overcast being the cloud cover. Versus an obscuration in globe is whenever there's 25% or more of your sky that you can't see because something is in the way, like dust or smoke, that sort of a thing. That's an obscuration. And you can still click obscuration and submit to us photos of that obscuration if it's safe for you to be able to do that. Now, you may have noticed also that that percentage cover that we were talking about, that you are using these categories, which are pretty broad categories, but that should help give you confidence in helping to figure out exactly which one you want to stick your observation into. And I will say to you that the more you practice cloud type, cloud cover, everything in the app, the better at it you're going to get. And so please continue to do it, but also know that we have some resources there. So we have that little question mark button, and we also in the app have this thing called the Cloud Wizard. The Cloud Wizard is set up to be very much like a dichotomous key that says, do you see this? Yes or no? Do you see this? Yes or no? To help get you to what might be the cloud type that you're seeing in your sky. The Cloud Wizard can also help you estimate that cloud cover. So you can, the Cloud Wizard's there for you to use to help you figure out your cloud type and cloud cover, or you can decide you don't need to use that and go ahead and select away your cloud type and cloud cover. Those of you just are coming back, I'm just stepping everyone through what you have seen in the app and just kind of going over that. Now, if you wrote overcast, you probably didn't get the option for sky color and visibility. We actually only ask if your sky only has few or scattered clouds, we'll ask you this question because we're asking about the sky color, not the color that might be because the cloud is in front of it, but rather the actual sky itself. And so you're looking for the deepest shade of blue, which is typically when the sun is behind you and you look up, that's the deepest shade of blue typically. And then when you're doing your visibility observation, you're looking at along the horizon. So much like they would do at an airport, if you have something in the distance that you would use on a regular basis, you'll get pretty comfortable with doing visibility. So maybe there's a tree, a building. If you do have a flag, you could use something like that. Now, opacity. This is the part that's really interesting, along with the height of the cloud, which would indicate its coldness to us. But this opacity is about how much light is allowed to come through the cloud. And so when you're telling us opaque, translucent, or transparent, you're doing that at each level. and you're going to take roughly what is the most that you see. So for example, if I go outside and there are a lot of cumulus clouds and some just being developed, some of those cumulus clouds that are just forming may not quite yet be opaque, but around me I've got some big puffy opaque ones. I'll enter opaque. So that gives you an idea. If you want to enter kind of what is the predominant opacity that you're seeing. And another way to help you with opacity is, do you see a shadow? Do you see a shadow might be a good clue to help you with opacity. If you see your shadow, then it's probably transparent. If you can't see your shadow, it's probably opaque. Now, in terms of surface conditions, these are just yes, no questions. Something like pine needles, for example, we always get asked about pine needles. Pine needles on a tree would be yes, leaves on tree. And you're looking for up and down. It's all right if your feet are in there. Turns out it's very hard to make that down photo without getting your feet in there. And we're really looking at what the satellite might have also seen, because as you know, sometimes satellites have some trouble with the detail, whereas your feet are right there on the ground. You know whether or not there's snow or ice on the ground, standing water on the ground, but that's really helpful to us. And then your pictures, you know, you probably got to have fun rotating your phone, trying to get that little circle into the spot there. And what we're doing is we're angling your phone so that way it's just above the horizon. So that way we're not looking straight across the horizon, because that makes it hard to actually estimate cloud cover or cloud type, right? Because visually they're all smushed together. So we actually use in Globe what we call the 3/5 rule. So putting your fists out above the horizon, 3/5 up, we're looking at the sky here as opposed to what's close along the horizon there. And that's what we're doing with this phone angle. Now, the most exciting part of Globe. Oh yeah, go ahead, Marilei.
Ted was asking if you could review the photographs because he had a bit of difficulty. Maybe talk about if you move your torso around, you'll see the letters.
Yeah,
and
so
Ted,
the first,
if you're still here, if you can tell us what made it difficult to take the photographs?
Yeah, so the first thing is you have to turn your phone. Is the first step in that. For most phones should automatically get this directional thing working. And as you turn your body, physically I'm on a chair that turns. As you turn your body, you should see the letter change to the cardinal direction that you're facing, and you're trying to get that white circle into the black empty circle on the screen. It's probably hard to see in this, but that's exactly, you're trying to get that right in there. And then your camera should automatically take the photo and save it. If that doesn't work, there is an option to manually add photos, but this is typically the easiest way to do it. And if for some reason you were having trouble, please feel free to send us the make and model of your phone so we can double check with our web developers that there's nothing going on with that. Thanks for that. So I do want to mention about satellite matching, because in the Globe Clouds protocol is the only protocol where we are proactively checking your Globe citizen science observation to see whether or not we have satellite data from the same time and location. So that is exactly what our team at NASA Langley does. So we compare your observation to various satellites. So for polar orbiting satellites, we check with Aqua, Terra, and Calypso. And we also do geostationary, which means basically almost any time of day from most locations, we can get a geostationary match. And when we get a match, we tell you what the match was. And so we will email the same email address that you used when you created your account for the Globe Observer app. We will email you a personalized email from NASA with a table that looks like this on the right-hand side, comparing your ground observation to what the satellite saw. And it might not be the same, because your perspectives are different, right? You are on the ground looking up. So you see that low deck of clouds predominantly. A satellite in space looking back at Earth is going to see that high layer of clouds first. And so you have very different perspectives. The other thing is, think about from a satellite instrumentation perspective. If we're using a camera, there are lots of things that look like clouds. So snow predominantly, right? So snow is white, clouds are white. If we were using IR instrumentation from our satellite, then clouds are cold, snow is cold. So it can sometimes be tricky from a satellite perspective to tell some of those differences, whereas you have no trouble distinguishing the difference between snow and cloud because here is where you are. So that's one of the examples. Thin cirrus is another example that we always can use some help with. And of course, contrails can be very tricky to see with satellite because for polar orbiting satellites, they're just not there long enough. Now, we did get a few of these numbers just to give you an idea of how many data points we get. Well, we get over 200,000 observations in a given year, and we're actually able to match over 80% of them with a satellite observation. So that's awesome that you will be able to get an email back saying that, but that's also data that's freely available to you, the public, and researchers at large. And so that's another thing that we do is we create data sets that have these globe citizen science observations paired with whatever satellite data that we have, and it's available through our website, observer.globe.gov. And if you look at Get Data, you'll be able to find that. And you can also see your observations that you just made more directly by going through what we call the Globe Viz tool. And I put the URL here, viz.globe.gov/globe, directly on the Globe website. And it's also embedded on our data challenge page. You can see your observations and the observations of the 200,000 plus citizen scientists around the world, and basically real time. And we are using this data to help our research, and you can access those publications again through that website itself. So I did a little teaser for the data challenge. We are currently in the middle of a data challenge where we're basically just asking the community during this time period to really help us fill our data set. I told you we get over 200,000 observations in a given year. During a data challenge, which is usually for us 1 month long, we have been able to get 40,000 observations in that 1 month alone. That's really awesome for us to be able to do some really exciting research when we have that amount of data density in a short amount of time. So we ask for you to please consider contributing to the Cloud Challenge that's running right now through February 15th. Of course, as you know, clouds are exciting all the time, so you're welcome to make observations beyond this. But this is a point in time where we're going to be using the voice of Globe, social media, and NASA to really promote this. And you can participate through the Globe Observer app, and then also through our Cloud Gaze, which is what Jason is going to be talking about, which is our partnership with Zooniverse and how your photos wind up getting shared on the Zooniverse platform. So I'm going to go ahead and hand it over to Jason to talk more about Cloud Gaze. And I'm going to hop into the chat if you guys have any questions about the Globe program or how to use the app. Thank you. I hope to see your photos and observations coming in here.
Great. Thank you so much, Jessica. And yes, so I'm going to now share. Sorry, give me a little bit of time here. I'm now going to put this in presenting mode so we can actually get this. There we go. Yes, so welcome. And let me actually also put my video on. It might also help us. All right, give me 1 second. All the little Zoom issues here. The video on, you can actually see who I am. And here we go. Okay, now that I see the little light is on here, that's good. Okay, so once again, welcome to our session here and to NASA Globe Cloud Gaze. We are so happy that you're here. And now what I'm going to be talking about is kind of what you've heard about before, but now the photos that actually get placed into the system. Now, once again, my name is Dr. Jason Welsh. I'm at NASA Langley Research Center. And essentially, just get rid of that, and I'm a research scientist there. So a little bit about me. So who is this person, right? Who is this Dr. Jason? So I actually worked with a man at NASA Langley called Jack Fishman, who's an ozone-related specialist. And we actually did work at NASA Langley about 13 years ago. And basically, I had such a great experience that him and I decided, you'd actually be really good to get some more education at a university. And it happens to be he was going to be teaching at St. Louis University. So I then went out with him for about 7 to 8 years and actually did teaching really also that, but also did my master's and my PhD at St. Louis University. Absolutely loved it. Once I got done with St. Louis, I said, okay, what am I going to really do, right? I mean, okay, I'm done my master's, my PhD. I had in my mind that I really love teaching. I love explaining concepts to students, to adults, etc. And so I then went down to Boston, began to teach and do my professor sort of work down there. But I also, at that same time, said, I really also enjoy the research. So why don't I go back to the research and let me try to do that? So I have been enrolling in the NASA's postdoctoral program. Got in there, was absolutely ecstatic, and really was very excited. I absolutely loved the research that I did there within that program, but I also had missed it. Once again, I went back to teaching. And so the beauty of what I'm doing now is it's kind of both, right? That I get both the teaching aspect, what I'm doing right now, but I also get the research and the real research component to this. So that's a little bit about me. And so, okay, so globe observation, the publication. So citizen scientists, observations from the ground are very useful to scientists because of their unique view. As we've seen, as Jessica showed you, basically there are, you can get a unique view of where you're looking up at the sky. Now, there are multiple publications available on how your observations have been used in actual research for multiple observations that you can do within the Globe program's Globe Observer app, which you just downloaded. This includes, as was mentioned, again, cloud, that's the most important one, or at least I guess we're a little bit biased on that one. Tree height, land cover, and mosquito habitats. Now, a picture is worth, as we all know, 1,000 words, maybe even 1,000,000 words, right? And one of the most requested observations you can kind of go figure, right, are photographs by citizen scientists. And in this example, you can kind of see that there's like this dark area. It looks like it could either be smoke or dust covering the sky. But photographs, they allow, again, scientists to be right there with you. Now, that's not quite literally right there with you, but we're able to, based on your observations, we're able to see, is this photograph, what's going on with what you're seeing there? Now, the interesting part about this is, for example, there's cumulonimbus clouds in Costa Rica, okay? So somebody observed this. And what's kind of cool is that if you're looking at the sort of the right-hand screen and then on the left hand is the observation. So it actually shows the picture, it shows the image that somebody snapped with their photo. And on the right side is an image of a satellite view. And as you can see, basically, by and large, I mean, if you want to be really picky, you can say, well, they're not exactly, but by and large, they're pretty much equal, right? There's a similarity there that we can pretty much see that one looks pretty similar to the other. Now, not only can we just do it with just clouds, we can also do it with unique events. So in the Canary Islands, we have a volcanic eruption, right? So this is a very unique event. We don't typically see those in our backyard, just exploding. So this is a very, very unique event. And again, you can pick up based on your photos, which is really good. Or we can also confirm it using satellite image. And this was from November 15th, 2021. Now, having classifications of clouds, unique events, and those, a few times when the photograph was taken inside a building, etc. at night, blurry, they're actually very, very useful. And they're useful when you're trying to analyze, there's citizen science background observations, when you're trying to sort of analyze things. They, even though we do prefer outside, they are useful in terms of, just having some sort of view. Now, for the very dark image there, for the black image, that is a little one that we're not quite as interested in, just because it is so dark and really not seeing any clouds. But once again, you can have a dust image, a haze image, even a smoke image. Now, so this is how the idea for NASA Globe Cloud Gaze came about. This is how it all kind of wrapped up and formed itself. So a partnership with the Globe program and the Zooniverse online platform, we asked people like you to identify cloud types, cloud cover, and other unique events in photographs taken by participants in the Globe program. And as you can see, and as you've already done, you can get a north, south, up, east, west, and then down. And of course, in this image for down, apparently there's no feet. I guess the person got it just at the right angle or kind of tilted it. Now, you might be asking, okay, great, but how do I participate, right? I mean, how do I actually, get involved in this, right? I mean, it's great that we're talking about talking about all this, but how do I participate? So what you can do is you can go to this web address at the very bottom. It's very dark, but I'll kind of read off. It's https://www.zooniverse.org/projects/NASA Globe /NASA-Globe-Cloud-Gaze / and that will actually bring you to what you see right here, right on your screen here. And so with that, let's do a demo. So now I'm going to go out of this screen, and let's actually do a demo of what you're going to kind of be able to see. So if we go here, and I want to make sure, I think we've got, here we go. Okay, so this is what you will see when you first get logged in. So when you go to this exact address up here, this is what you're going to see. And typically, you're going to see NASA Globe Cloud Gaze. You're going to see a blue area here where that basically indicates that there's certain things that we want you to be aware of, or if you're struggling with, maybe even come to this area here. But if you scroll down beyond Learn More, if you go to Get Started, okay, so this is where it all sort of happens. And so if you go to Get Started, there's either two options. There's cloud cover or what do you see? Now, either one is good. They're not the cloud cover is better because it's first and that one's second. We do want from both. And so if we do cloud cover, we click on that cloud cover example, it brings you to this image here. Now, clearly, this is probably more of an up image. It looks like we're looking directly at the sun. But in this case, we're thinking about cloud cover. Okay, now, so what do we see? Now, in this case, I would say I don't see any clouds. So what I would do then is I would think, okay, do I see few, isolated, scattered, broken? Is it overcast? Or are there other stuff? In other words, is there a big tree in the way and you can't really see? I mean, you can see the cloud, see the sky, but it's really just covered by a complete covering of an actual tree or of an actual building. Now, so once you've done that, I would say probably fewer than few, which means really less than 10%, which really means just clear. So once I've done that, I can either click Done or Done and Talk. And when I click Done and Talk, this image, the very image here, will actually go to our talk section of Zooniverse, basically. And so that will go in there, and then your comment will be right below. So the image will come first, then right below will be your comment, your question. Feel free again with the Done and Talk to just submit in, hey, this is a cool image, right? We have people that actually do that. If it's a question, that's even better, right? We can converse back and forth. So that's how you do the process within sort of Cloud Gaze. Now, okay, so now back to this here. Okay, so now with this, why does this matter? Okay, so what is this, what is this going to really do for us? Now, photographs help scientists like myself understand these mismatch reports. So investigations can actually move a lot faster if photographical information is already published with the if it's already published with the report. And so satellite reports, let's say that they do, a total of 100%. So the satellite is seeing 100% cloud cover at high levels. Well, say the globe participant reports less than 90. Okay, so probably like 90 to maybe 95, right? There's some range, low clouds. We see that really based on that, whether it be 100% for the satellite or, greater than 90%, the both are they're going to be pretty much equal. And if you look at the very bottom here, you can actually see that this is very true, that the satellite, this is the yellow is the satellite-based column, that it's actually saying overcast, that's right here, and that's at 100% cloud cover. And yet, what the actual observation, the person saying, is it's about greater than 90. And when you look at the actual pictures, both here or even down here as well, but when you look at these pictures, yeah, I mean, that looks like probably greater than 90%. And so the low clouds are present in the photographs. There we go. So the best thing about this is the fact that, that you can do a chat, okay? And so, this is by far, again, that I've seen stressed. We've had many meetings that the chat, the talk, as we call it in Cloud Gaze, is so vital to really getting us to be able to communicate. If there's a problem, if there's an issue, we want to know about it. But also we just want to know, how's it going? Are you enjoying it? This is really what we really want to know. So please join this conversation of scientists and other citizen scientists. So it can be citizen scientists that are sort of talking with each other, or it could be myself. Now I'm on this chat, and feel free to go to the project to the same link, just /talk. And there, once again, you can, we usually try to do a what's happening in the atmosphere for this week. There's an educator section. There's one where you can introduce yourself. There's just a lot of really exciting stuff happening. Now, with this, now I'm going to show you, and thankfully it did pop up. I'm now going to show you what we have for you. We have something really exciting, and this was talked about by Jessica, but we have this Cloud Challenge 2022, and here's a video to show you what it's all about.
Did you know that clouds can both warm and cool our planet? Keeping an eye on clouds helps NASA study our climate. We need your help capturing data about clouds where you live. NASA Globe Cloud Challenge 2022, Clouds in a Changing Climate. January 15th to February 15th, 2022. Participate by taking cloud observations with the Globe program's Globe Observer app, or by classifying cloud photos through Cloud Gaze on the Zooniverse online platform. Learn more at observer.globe.gov/cloud-challenge-2022.
Okay, so that is our Cloud Challenge. Now, see if I find my mouse here. There we go.
Did you know that
okay, and there we go. Sorry. I don't know that plays a second time. So this is our Cloud Challenge, starting as of January 15th. And as of January 15th, it's already started, and it's going until February 15th, 2022. Please do visit the https://observer.globe.gov/Cloud Challenge 2022. Now, there are two ways. You might say, okay, how can I participate, right? I mean, let's face it, maybe, are there other different ways? And there are, yes. So first off, if you say, I really want to move around. I actually want to do something for this. I don't want to just be on the computer. We do want people to actually take, as you just did, globe cloud observations by going outside. The one thing we do want to make sure, is that you are following, local guidelines. You don't want to go to a military base and be trying to snap pictures. That may not go so well, right? And so on the other hand, if you say, I'm not really so much into this whole going outside, checking things out, why not you can do it through the Zooniverse, which is NASA Globe Cloud Gaze. And you can go right to the website and do what we just did for both cloud cover and the what do you see as well. And for both things, these both are very valuable in terms of getting images into the system, but also analyzing images. And also, feel free to do both, right? You may just say, hey, heck, I'm just going to do them both. So please do feel free. We are really excited to see what images will be brought into the system. Now, finally, there are many, many other ways that you and other citizen science projects related to Earth, space, and beyond on NASA Citizen Science webpage. This is not the only one. Of course, again, we're a little biased. We love clouds, but please do participate in any way possible. We're all for bringing the scientific community together and really and the scientific community and the key part is the citizen scientists, the people who can really contribute wherever they are. So with that, here's my email address. Please, again, feel free to contact me. I will get the email, of course. It's jason.r.welsh@nasa.gov. Please feel free to contact me. I will then distribute that to my colleagues or converse with them, or I can either answer it myself directly. Kind of depends on the question. But with that, I will just say thank you so much, and we look forward to your questions now. Thank you.
Thank you to everyone who's been asking questions in the chat. And I want to give a shout out to Marile Colon Robles, who's been diligently answering a lot of your questions. So hopefully we haven't missed too many of them, but you can always reach out to us if we did.
Well, thank you all so much. And I see that there's still questions. You can answer those in the chat. But I just want to say a big thank you to Jessica and Jason and Marile for your talk today. Thank you all. We're going to take a break in about 2 minutes. It's going to go for about 5 minutes. So that's going to be at 2 p.m. Eastern until about 5 p.m. Eastern. Give you a chance to get up and stretch, drink some water, maybe enter in a globe observation or two if you have the time. And then we'll be back again at 2:05.